everyone, from a box containing 3 red balls and 5 green balls, so that's a total of 8, 2 balls are randomly picked, one after the other and without replacement. The next video I'm going to do is the same problem with replacement. But what we're going to do is answer 4 questions. The first 2 are, we're going to draw a tree diagram showing the probabilities of each branch of the tree and determine if the event's second ball is red and first ball is red independent. So let's draw the tree diagram. So we're drawing 2 times. So for the first branch, you draw a ball. For the green ball, that would be 5 out of 8. And for the red ball, that would be 3 out of 8. Now, we don't replace it, so now we're going to go ahead and do green-red again on the second draw. We don't replace it. Since we're not replacing it, all these denominators are going to be 7 because we already have we only have 7 balls. So basically, if you draw a green one first, then you only have 4 green left, so that's 4 out of 7. If you draw a green ball, we still have 3 red balls left, so that would be 3 out of 7. If you draw a red ball, then the green ball, we still have 5, so that's 5 out of 7. And the red, if you draw a red the first time and don't replace it, you only have 2 red left. So that's the tree diagram. Now, they're asking, are the events of the second ball is red and the first ball is red independent? So basically what we're saying is the probability of second is red, given that the first is red, should equal the probability that the second is red. So the probability that the second is red given the first is red, so the second is red, are these two, given that the first is red. So that one is going to be 2/7 times 3/8. And that equals 5 divided by 56. Now, the probability that the second is red is these two. So we just want the second is red. So that equals 3/7 or 2/7. And that's going to be 5/7. And that's going to these two don't equal, so they're not independent. Now the next 2 questions are, find the probability that both the balls are the same color. So that means the probability of red, red, or probability of green, green. All right, according to our tree diagram, the probability of red, red is 3 divided by 8 times 2 divided by 7. And the probability of green, green is 5/8 times 4/7. So multiplying this out, you get 6 divided by 56 plus 9 divided by 56. No, this is 20, sorry. 20 divided by 56, which equals 26 divided by 56, which is reduces to 13 divided by 28. Now, find the probability that one of the ball is red and one is green. So basically we're doing probability that they're not the same color. So we already did the probability that they are the same color. So we're going to use our complement theorem and say 1 minus the probability of the same color. That's going to equal 1 minus 13 divided by 28, which equals 15 divided by 28. Usually with these ones, what I do is I just write the denominator. I just write it over the 1. So it makes it easier if you're not using a calculator. And that's it. Thank you. Have a nice day. Bye-bye.